So, Simon, a few questions for you. The first, what are your thoughts on the genomic technology called optical mapping?
Yeah, thanks, Ren. So first off, I'd like to reemphasize our belief that sequencing and mapping are complementary technologies, each one with its own part in a Venn diagram. So, we don't see this as being a zero-sum game by any means. And I wrote a Twitter thread about this, mostly to dispel what we felt were, improper comparisons between these methods based on things like price, variant detection, and the use cases. So that seems to be how most folks read it. Still, the feedback that I've gotten from doctors and bioinformaticians has changed my view in two places. So I'd like to outline what those are. The first is that large structural variant sensitivity, changes and improvements in sample throughput and quality assurance software put the Sapphire instrument, which is an optical mapping instrument, in a good position to simplify from legacy cytogenetic methods, things like FISH or karyotyping that are tedious, to say the least, to handle in some of those pathology labs. So the second thing is that improving the ability for long-read sequencing platforms, so not mapping, improving their ability to detect large structural variants is probably going to come from neural network assisted variant calling, such as Google's deep variant, instead of the extension and read length. So those are the two sort of main changes that I've had from my communications. So I'll just end by saying that we still maintain the belief that hi-fi sequencing provide the single most comprehensive method for variant detection across all types. And as such, we think should become standard for many clinical applications, such as whole genome sequencing, provided that the costs and the throughput improve over the next few years. So, over the past decade, long-read sequencing has improved roughly 10,000-fold in throughput and declined about 50 times in price. So that we think that by the end of 2025, as we've modeled through things like the price elasticity of demand, throughput improvements, as well as the ocean of population scale data that is coming through various corporate collaborations, long-read sequencing, inclusive of all vendors, could grow to essentially a $5 billion revenue opportunity by 2025. And so with that, I'll say that, we've got more meetings lined up with bioinformaticians and people that really operate in the sequencing tool space to try to continue to evolve our opinion. So if anything else changes, I'll be sure to let people know, but that's my pulse of where, my understanding of the technology is now.
Great, thank you. Another question for you, Simon. What are your concerns with Illumina? Share your thoughts there.
Okay, so a couple things. We don't necessarily agree that AI-driven improvements, on the short read side will be able to improve the variant calling, far beyond about 50 or 60% of structural variants. We also think that the smaller single nucleotide variants, are very difficult to detect depending on the sequence context, like in very repetitive sequences. And we don't really think that the path that Illumina has chosen is going to be able to contend with the trajectory that a lot of the native long-read sequencing platforms seem to be on. And even with another order of magnitude drop in price for short-read sequencing, we think it's becoming steadily more obvious to researchers, population geneticists, and honestly, many of the diagnostic companies that we speak to, that longer reads, the ability to detect methylation, and the ability to phase chromosomes into parental copies is becoming a really, really important thing. So that affects the core business. And then lastly, with Grail, which Illumina recently acquired, which again, we'll kind of reemphasize, we think has really stellar science, machine learning capabilities and a driven team, we don't think is as clearly separated as a standout winner amongst some of the other players in the space. Some of the clinical data, which we've written about before, is a little challenging, we think, from a regulatory standpoint, insofar as it doesn't mirror the intended use population for this test. And we also are still trying to get our heads around the idea of molecular tissue of origin, which is something that Grail seems to be going for. this is not really matching what our oncologists that we speak to have kind of told us that they think would be most applicable in a clinical setting. So those are some of the reservations that are going on right now.